The final topic for 3D geometry or 3D shapes is going to be surface area. And surface area is just how much area there is on the outside of the shape. So we would just add up the area for each side of the shape, and then that would tell us how much surface area it is. So think about when you're wrapping a present and the wrapping paper has to cover the surface area, so you have to have enough paper. So surface area of rectangles or prisms are going to be fairly easy, and oftentimes we will talk about a thing called a net. So, for example, if we have this 3D box right here, then if we cut it so that all of the sides could be laid flat, then we might have something that looks like this. And nets can be cut in a variety of different shapes. But if we folded this up, then we would get the rectangular prism that you can see. And so if we know that this side is 5 and this side is 3 and this side is 4, then we can see that this would be 3 and this would be 4 and this would be 5 and 4 and 5 and 4. So if we calculate the area for each of these boxes, then we can see that the area for this box would be 12, the area for this box would be 15, 12, 15, 20, and 20. And then we would just add those up to find the surface area of the entire shape. So all we've done is find the area of each side of the rectangular prism, and then we'd add it up. So 12 and 12 would give me 24, 15 and 15 is going to give me 30, and 20 and 20 is going to give me 40, to give me a grand total of 94 units squared. So that's how we know that we're talking about surface area and not volume. So surface area just takes a little more time to calculate, but they're not difficult calculations. You just have to remember that it is the sum of the area of each side of the shape. If we were doing a triangular prism, then we're going to go ahead and draw our shape there so we can see it. So we would have to calculate, we would need to have more information than we would otherwise. So if we were doing volume, then we would just need to know the height and the base. But in this case, we need to know what all of the sides of the triangle is, and that's going to make it take a little bit longer to calculate. So it's the same premise though. We would still make a net. So this would have 3 rectangles. Oops, I didn't mean to separate them like that. And then it would have the triangles on each end. And so it is going to be a slightly more complicated calculation because of that, but you would still calculate what the triangles were, and then you would add them to what the rectangles were. So in this case, we need to know this dimension and this dimension and this dimension. So that means that these would all have whatever that blue dimension is. We also need to know the base and the height so that then we can calculate out what the triangles are. So that's how we would do that, but we would still add them all together. So this is going to have 5 calculations instead of the 6 that we had with the rectangular prism. Lastly, we do have cylinders. And so if we have a cylinder, it's going to look something like that. So it's going to look something like that. Well, the net for this is going to look like this. So you're going to see that we have the 2 circles that are the ends, and then we have a rectangle that makes up the center of it. And so in this case, we just need to know the radius, and then we need to know the height. So in this case, let's give it a height of 3 and a radius of 2. And to figure out what this side is, we need to calculate what the circumference of the circle is so we know what the length of that rectangle is. So for this particular one, for area, so we have area is going to equal pi r squared. So we've got pi times 2 squared, which is 4. So area is going to be 4 pi, and there's 2 of those. And so the area of the circles is going to be 8 pi total. And now we need to figure out the circumference. And that's going to be 2 times pi times 2. So also 4 pi. So my length is going to be 4 pi. And so that means the area of the rectangle is going to be 12 pi. And we're going to add that to our 8 pi. And we know that the overall surface area is going to be 20 pi units squared. And again, we can multiply that by 3.14 to get what the total would be. So it should be, it would be 62.8 units squared for the surface area of the cylinder. So you can see that triangular prisms and cylinders take a little more effort to do. The surface area of a rectangular prism is quite simple, but all we do is find the area of all of the different shapes when we lay it out flat and add them together to get the surface area.